Welcome back to Chem 101. In this video, we will talk about calculating percent composition, or as it's otherwise known, mass percent.
When we talk about mass percent, what we want to know is basically how much of a particular compound an element represents. Let me give you an example. Let's take the example of water. We know that hydrogen on its own weighs about 1.00 grams per mole, and we know that oxygen is approximately 16.0 grams per mole. So a water molecule would be 2 of those hydrogens, and if we added that together, we'd get about 18 grams per mole. So if we wanted to know what the mass percent of hydrogen in water was, we would simply take the mass of the total amount of hydrogen. In this case, it is 2, maybe that's not a good way of representing it, but it's 2 hydrogen atoms over the entire water molecule. And so that's about 2 grams over the entire water molecule, which is 18 grams. Now, since we're talking about a percent, we would multiply that by 100. And what we get is about 11.1%. So what this is saying is that hydrogen makes up 11.1% of the total mass in water molecule. And so let's calculate the mass percent for a variety of compounds. Let's calculate the percent mass of potassium in aluminum potassium sulfate. Let's also calculate the percent mass of, let's say, carbon in something like methane. No, let's make it something more interesting. Something like a sugar, C6H12O6. Let's calculate the percent mass of chlorine in CF2Cl2. And let's also calculate the percent mass of oxygen in something like barium sulfite. Alright. Let's go first with the potassium in the aluminum potassium sulfate. Alright, we need some molar masses. So the molar mass of aluminum, first off, we need the total formula mass. So that's going to be in aluminum, which is 26.9815 grams per mole. We need our potassium, which is 39.0983 grams per mole. And we need our sulfur, 32.065, and our oxygen, 15.9994 grams per mole. Okay, so our formula mass for aluminum potassium sulfate is going to be 258.205 grams per mole. Now, if you're unsure how to calculate formula mass, watch the previous video to this one. Okay, so now that we know what the whole formula is, here, let's just take all of this information back to our other page. Alright, so what we're looking for is essentially this. We want the mass of the total potassium over the mass of the entire molecule, which is aluminum potassium sulfate, times 100. And so that would look like 39.0983 grams per mole. over the total, which is 258,205. Our units of grams per mole are going to cancel here, times 100. And so our answer, which I'll write right up here, is 15.14%. So potassium is 15.14% of the total mass in the entire molecule of aluminum potassium sulfate. Okay, let's do the next one. Using the periodic table, we can get molar masses for carbon, oxygen, and hydrogen, and we can total up a molar mass for the formula C6H12O6, and it comes out to be 180.1559. Alright, so here we want the mass of carbon in that full molecule. So it's C6, so that means there are 6 of those carbons. So 6 times 12.0107 grams per mole. 6 of those over the weight of the entire molecule, which is 180.1559 grams per mole. Units cancels, times 100. And the percent mass of carbon in this sugar molecule is 40.001 grams per mole. Oh, not grams per mole. Percent mass. Or we could say by mass it is 40% carbon. Alright, let's do the next one. Using the periodic table, we can get the molar mass for CF2Cl2. And again, here we want the chlorine in this molecule. There are 2 chlorine atoms, so we would say 2 times 35.453 grams per mole over 120.9135 times 100. And the mass percent of chlorine in CF2Cl2 is 58.64%. Last one. Alright. Barium, oxygen, and sulfur make up barium sulfite. And we are interested in the percent oxygen here in that molecule. And so we want the total of the oxygen. In this case, there are 3 of them. So we'll say 3 times 15.9994 grams per mole. And the formula mass here is 217.3902 times 100. The percent mass of oxygen in this molecule is 22.07, or let's say 08% oxygen. Alright, so that is how you can calculate the percent mass of an element in a compound. Now we can use these as conversion factors, so let's take a quick look at that. If we were given this information, such as the percent of potassium in aluminum potassium sulfate, we could make a conversion factor out of that using that number 15.14. Because this is essentially saying that if we had 100 grams, and we can do this, we can just say that I have 100 grams. If I had 100 grams of aluminum potassium sulfate, that in that 100 grams I would have 15.14 grams of potassium. This is true anytime you see a percent, because a percent just means per 100. So this is just in every 100 we have 15.14 grams of potassium. Same thing could be said of the carbon in that sugar molecule. Every 100 grams of C6H12O6, well, that's not going to do, means that we have 40.001 grams of carbon. And we would write that just like any other conversion factor. We could say 40.001 grams of carbon in every 100 grams of C6H12O6. And vice versa, right? We can flip this around if we needed to help us go from, let's say, some number of grams of C6H12O6, and we wanted to know how many grams of carbon were in there. We would simply insert this conversion factor. We would get units to cancel, and we would be able to convert from some mass, as I said, in sugar into some mass of carbon. All right. I hope this was a helpful video. Please let me know in the comments. In the next video, we will look at density.